This question, like this question, like this question. Why would I say that, Nick? Did you hear me say it's going to be on the test? You're just the kind of student that tends to notice those things. And okay. Says this, if a 60-watt light bulb is left on all month, and let's assume this month is 30 days because months vary, 24 hours a day. What does part A want me to find, Amy? Find what? Keep reading. No, read part A. Find the amount of what?
Energy.
The amount of what? Say it again.
Energy.
On our formula sheet, what was energy? We had a letter, a variable for that. E. So let's write down E equals question mark. And hopefully just by writing that down, Mansion, you're already targeting certain equations on your sheet. Right? What else have they told me, Amy? What's that 60? And so which variable was watts on my formula sheet? What did watts measure? You weren't here for this? Sorry, I'm picking on you. I apologize. Oh, that's right. You were getting your shot. Okay, sorry. Nick, what's that 60? I know it's watts, but what is it? Yes! What letter? Okay. Hopefully already on your yellow sheet now, Amy, you're looking at an equation that has an E and a P in it and has the E by itself. You might even already know which equation we're going to go with. If I want to find energy from power, what else do I need to know according to my formula sheet? Time. So Cleo, how much time in this question? Just tell me.
30 days.
30 days. But we can't do physics with days. We need to convert that into seconds. How? Let's write down the 30. What will I do with that 24? Add, subtract, multiply, divide. Okay, I'm going to times 24 hours. And then how do I go from hours to seconds? I think I did put that on your formula sheet, didn't I?
By 60, then times by 60.
Yeah, but I gave a shortcut on the... didn't I say times by 3,600?
Yes.
Oh, hey, let's do that. It's less work. Or 60 squared, I heard Sarah say, if your calculator has the squared button, and I've told you you don't need one that has that, but if yours does, yeah, I would do it that way. Cleo, how many seconds is that? How many seconds are there in an average month? Not in February, not on the ones that have 31 days, but in the average ones. What'd you get? Calculate it, Cleo. And please make sure, especially if you don't have a scientific calculator, like Brianna, make sure or Halia, is there a scientific one or a normal? Make sure if you have just the cheap ones, try these to make sure your calculators can handle the numbers. Because if they don't, that's going to be a problem. I think we can handle all the numbers with a cheap, crappy calculator. Otherwise, you might need to bring your one from math. What'd you get? Read it to me.
2 million.
Just read me the digits, 2 at a time.
25.
25.
92.
92.
3 zeros.
3 zeros.
2 at a time. 3 zeros.
Yeah. Almost 2.6 million. Not quite. Okay. Nick, what equation am I going to use here? By the way, we're using our DFIC approach. So there's my listing my data. And then I always, while I'm listing my data, make sure my units are what I want. Then the next step is find an equation. Yeah? So here's my E equals P times T. Do I know power? 60. Do I know time? Have you all learned about your answer button on your calculator? That great shortcut? So Cleo uses a scientific calculator, yes?
Yeah.
Do you know where your answer button is? And do you know what it does? It's a massive time saver. So you've just gone 30 times 24 times 3,600. The last answer you have showing is that, yes? And we want to go 60 times the last answer. If you go 60 times and hit your answer button, it's way less typing and more accurate. So where is your answer button? On yours. Yep.
Got it?
Yeah. And it'll say ANS, and you get the right answer. That answer button there, by the way, is really handy in physics. Because often you're going to find something and you want to use that to find something else, and you want to use that. No, store it instead of retyping it. Especially if it's a yucky decimal that you don't want to write all the decimals anyways. Do you get 1, 3 5s, a 2, and 4 zeros? Yeah? That's what I'm going to write. A 1, 3 5s, a 2, and 4 zeros, and then I'll backspace with the commas. I guess the comma goes there, a comma goes there. 155,520,000. What do I measure energy in? What are the units? Joules. Now understand, if your parents got their electric bill in joules, that would freak them out. Can you imagine seeing 155,520,000 joules on your electric bill? That's just one light bulb. So we do not leave bills in joules. We finished with this towards the end of last class. We said, by the way, there's the I and there's the crunch. I'm not going to write this. You can handle this yourself, I think. Okay, let's go like that. Don't accidentally erase something I didn't want to erase. What went here is 60, right? Okay. Brianna, what's B want me to do? Keep reading. Oh, so let's take our answer from A. That's why it says repeat A. So repeat our answer from A in kilowatt hours. On your yellow sheet, is there a way to go from joules to kilowatt hours? There is. Find it, find it. I think it's near the right-hand side somewhere, is it not? Yeah? Okay, how do we do that? First, we write down what we have, which is the joules. I'm going to write down 155,520,000. What do I do with that number to go to kilowatt hours? Multiply? Don't mix that up, right? Now, I always write divide like this. 3, 6, and how many zeros? 6 zeros? 2, 3, 4, 5. Cleo, do you have an answer button?
Yeah.
Is this number the last number stored on your calculator? It's way less typing. If you just right now, without hitting anything else, if you just hit your divide, most of your calculators will assume you want to put the previous answer there. Try that. Does it? Yeah. Way less typing. And then 3, 6, 1, 2, 3, 4, 5. Has no one showed you this answer button thing in your math classes?
I just knew the button.
Oh. If you take Physics 11 and Physics 12. Connor, do I teach you how to make your calculator sing? Yeah, because if I make you buy a good one, but I'll show you how to use do I show you how to use the equation solvers if your has that built? Yeah. What do you get? Did you get 43.2?
Yeah.
See, that is a much nicer number, kilowatt hours, and the abbreviation for kilowatt hours is KWH, kilo, W watt, H hours. That's a much nicer number to see on your bill, as opposed to 155,520,000. You'd freak out, okay? But this I can kind of track in my head. How many kilowatt hours does a bulb use? About 40. 43.2, about 40. That I can do math within my head and kind of, I want to lower my electric bill. I can track that. Is that okay? Mara, what's C want me to find? Kilowatt hour. The cost. Is there an equation on your yellow sheet for cost? And I'm making you look because, just like with the periodic table, I'm trying to train your eyes where to look on your sheet. There is, yes, is there not? What's the cost equation? What would be a good abbreviation to use for cost? I'm lazy. You can write the word cost if you want to. You know what? That works for me. A C would work for me. I'd take a C as well. But let's abbreviate. Organized, though. What would be a stupid abbreviation to use for cost? X, the letter that they always use in math for the unknown, that's a dumb letter to use. And use the first letter of what you're trying to find, unless there's a designated letter. Sometimes, like current, use I, not C, because that's the designated letter for current. What's the cost equation? Kilowatt hours. What is the kilowatt hours in this question? You mean the reason I saved part C for last is you had to do part A and then part B to get to C? Do you think I'll probably set the test up that way too in Kanyawaku? Really? I'll go in order for a reason? Okay, 43.2 times 7 cents. Why? Look up. Why is that wrong? That is wrong. Why is that wrong?
It's $7.
Okay, so how do I change it to cents? And this goes, I finished off last class with this rant, but it's worth repeating. This is a problem. Oh, Mara, I'm going to go times because it's going to fill in my answer button for me automatically. Yours does that too, yeah? If you just hit it does. Nice. Way less typing. Here's the problem. Our electricity is too cheap. If you leave a light bulb on the entire month, 24/7, what's it cost you? $3. There's not a good financial motivation to turn that bulb off because most people, basically $3, it's about 10 cents a day, a dime a day. Our electricity is so cheap because we're very efficient at producing it, but we're still telling you to turn the light off. Why? Because we want to help our environment. Because if we don't conserve electricity, we already, without realizing it, without knowing what we were doing, we damaged British Columbia's environment by building our dams. Hydroelectric power, after you build the dams and destroy the salmon runs, is a very green source of power. But you're destroying salmon runs, and you're also, when you're building the lakes behind the dams, you're covering over a bunch of trees, and that's carbon that goes back into the system. And you may have heard that we're a little concerned about carbon in the atmosphere. We didn't know back then. So we're trying to avoid having to build new ways to generate electricity. We're also looking, have you heard the word renewables recently? Okay, so we're trying to find ways that we can use wind power and solar power and tidal power and other ways to generate greener electricity. We're also hoping maybe we might be able to do something with nuclear fusion. There's a fusion company in Burnaby that's world class, and they're hoping to build a fusion reactor. A fusion reactor would give us pretty clean, pretty unlimitless sources of energy. $3, and I guess you know enough to know you always round off to pennies, right? You wouldn't put the 4? Okay. Now, in math, that 4 would say keep the 2 as a 2. They would round down. Do you think they ever round down on your bills in real life? So just to let you know, on the bill, I guarantee, Marco, this would be $3.03. The government or any company, they're not going to take that loss. They're going to pass it on to you. So is that okay if I gave you one like that? Multiple step questions. I like this question, I like this question, I like this question, I like this question. Read the question to yourself. And what I want you, while you're reading, is just ask, what the heck are they asking me to find? You might be able to spot that without even reading the whole question. You might see the question words, and you might say, what are they asking me to find? Petco, what are they asking me to find? How do you know? What's the phrase that told you that? How long? I'm going to write down T equals question mark. And I hope now on your yellow sheet, you're already looking at equations that have a T in them. Now let's go to the beginning, Petco. We're looking for numbers. I see a 10. What's that 10? So what is it, first of all, a measure of? Okay, so it's energy, and it's 10 kilojoules. I wrote the units down because these are yucky units. We don't do physics with kilojoules. How do I change kilojoules to just joules? What do I do with a kilo? Is that on my yellow sheet somewhere? It is? What do I do? Can I do 10 times 1,000 in my head? If you can, you don't need to write that step. You can just go equals 10,000 joules. If you can't, if you're calculator dependent, go ahead. But let's do a little math in our heads. Petco, I keep reading. I see a 30. What's that 30? Yeah, it's ohm. Oh, R equals 30? And the units are good? I see 120. What's that? Oh, in fact, you know what? It's a plug. I'm making up a good question. And the units are good. It's not kilovolts or millivolts. It's volts. Okay. So V equals 120. Any other numbers? Okay. What am I trying to find? There's got to be an equation that has a T by itself. Is there one? What's... Oh, this is... Wait a minute. This is a multi-step question. I need power. Okay. So now, what I usually do, the thing that I'm trying to find, I put a question mark next to, and then I would say power equals, I usually put a blank next to the thing that I need to find in order to find the thing that I need to find. Does that make sense, Julia? This is my own system. Whatever you come up with, again, I tend to abbreviate and be organized at the same time. So here's my question. Petco, is there any way I can find power? How do I find power? I don't know, time doesn't help me. Gotta be another way to find power. Now here's, ready? Stop, look up. What other things do you know? I see a V, I see an R. Find me a power equation that has maybe a V or an R or something like that in it. Sorry? No, I don't need to do that next. That's the third step, and you've taken... I will have to get there, but walk me through why we're getting there. What power equation are you looking at, Petco? I think, are you not going power equals... Yes? Now, Sarah, this is now the third chain of reasoning. This is why this is a multi-step question. And this is what electricians are doing all the time. And honestly, for an electrician, you get to the point where you're doing most of this in your head. But, okay, do I know V? Do I know I? Is there an equation that has an I by itself? What? You see the chain we're building here? Do I know V? This is why I list things, so that you don't have to think too hard, right? This is why it's worth taking that 1 second, list everything. What's V in this equation, Sarah? Do I know the resistance of this hot dog? By the way, Leo, I think what we're talking about here is either literally plugging wires into a hot dog, or honestly even roasting it slowly. This is how much energy it's going to take. More power means doing it faster. Less power means doing it slower. But it's going to take the same amount of energy no matter what. What's the current here? Is it 4? Okay. Now, Julia, I want to be organized but lazy. Somehow I want to show so that when I look later on that I plug this into the power equation. Look up, everyone. I draw an arrow pointing towards the next equation. There's my high-tech system. I think, Brooke, you'll figure that out when you look at it. Oh, it went into there. Okay. What's the voltage, Brooke? I know I caught you zoning. I picked my audience well. David's going to be next because he's stretching. Look up. What's the voltage? We've listed it. Find it. Yeah. What's the current? We just found it. Look at the arrow. I think you're right. I just can't hear you. 4? All right, my children. How many watts of power are we using? 480? Yes? Where is that going to go? I'll draw an arrow pointing to there. You see how you can kind of, when you study or look at this later, you can follow your reasoning and follow the arrows? Is that okay? By the way, if you want to write more, you can. Now I will substitute the power into the E. You can write all that if you want. All right, here we go. Time is... Petco, you're going to finish this off. What was energy? How much energy were we using to cook a hot dog? You listed it. You wrote it down up there. No, energy. Look higher, look higher, look higher, look higher, look higher, look higher, look higher. And I love that. Oh! Yeah, it should be that obvious now. 10,000, yes? Divided by how many watts of power? So if you have a 480 watt hot dog griller, what's the fastest you can cook the hot dog? Sorry? So now it's going to be 10,000 divided by 480, 20.833. I'll call it 20.8 seconds, 21 seconds. Hey, supposing you had a microwave oven, and you knew that microwave oven was 800 watts, and you want to nuke a hot dog. How long would you nuke it for? You would go 10,000. This is how they give you the cooking times when you're looking on the back of microwave oven products at the instructions. You take the amount of energy required to cook it. You divide it by the wattage of the microwave. That's the time it would tell you. Now a hot dog, 20 seconds on a hot dog, if it's not frozen, it's probably done through it. But also, nuking a hot dog is pretty yucky. They don't taste great. So don't do that. Is that okay for a multi-step question? I am going to give you a couple like this, David, where you have to say, well, now what? I'll give you enough information so that you can find something, and maybe find something to help you find something. We have to find two things to find the third. Sandy spends 20 minutes straightening her hair. During this 20 minutes, the straightener uses the same amount of energy that the 60-watt light bulb in Sandy's bedroom uses in 5 hours. What's the power rating of the hair straightener? Show all your calculations. David, what's this question asking me to find? Yes. Again, I'm not a fan of math problems, of word problems in math, because they're always like find the age, or 3 times a number is 4 times another. Those are dumb. One of the nice things about physics is figuring out what they're asking you to find is usually pretty easy. What letter am I using for power? Okay, so I'm going to write this. I have no idea where I'm going with this, Jordana, but I know I can get this systematically by listing my data, finding an equation, and going step by step. I'm not going to panic. What equations have power in them? V times I and E times T. David, I'm noticing they're giving me time, so I think I'm going to be using the power equation that has the time, the T, in it, because I see 20 minutes and 5 hours. Okay. So can you read me the equation that has time in it for power from your yellow sheet? Nope, the power equals, but it has a T in it.
Power
E over, yeah. How much time are we using the hair straightener for? 20 minutes? That's my time value. Why don't I like minutes? Okay, so up here where we're listing our data, let's write T equals 20 minutes. How will you change minutes to seconds? Okay. So it's going to be, is that 1,200 seconds? Okay. So David, you agree with me that 1,200 is going to go down there in a little bit? Yes? What else do I need? Okay, so ready? It says this. The straightener uses the same amount of energy as a 60-watt light bulb uses in 5 hours. I think I'm going to figure out how much energy the bulb uses, and that's going to be the same number. So now, I'm going to draw a little line. And I'm going to make a little heading here. Bulb. David, what do we know about the light bulb? What is that 60? Would you say 60? I don't know if you, maybe I cut you off. What's that there? What do I measure in watt? You're close. I think you were going to say the right word if I was reading your lips. What's measured in watts? Nope, sorry. That's joules. Nick, what's measured in watts? Wow, that was a bit of light. Yeah, power. Okay, so, but David, this P is not this P. That's why I drew a line and I put a heading for a light bulb. Power that we're using in the bulb is 60. We're in the light bulb, we're in the light bulb, we're in the light bulb, we're in the light bulb. David, what's this 5 right here, my friend? For the bulb? 5 what? Yuck. How do I change hours to seconds? I think it's on there. I think. Hours to seconds? Careful, read careful. Hours to seconds. No? It's not the... Nick, can you show him where it is on the sheet? On his sheet? Is it on there? It is on there, isn't it? Yes. Okay, see where that is, Nick? Because I'm absolutely going to give you time in hours because that's often how we measure time. Okay? So on your calculators, everybody, how much time is here? 5 times 3,600. I can do it in my head. Is it 18,000? Mr. Duke, how did you multiply by 5 so quickly in your head? You times by 10 and divide by 2. Old trick. 36,000 divided by 2, 18,000. Old trick. David, listen close. It says this. During this 20 minutes, the straightener uses the same amount of energy that the 60-watt light bulb uses in 5 hours. We want this energy. It's going to be the same amount of energy here. So I'm going to argue we can find this energy. You okay with that argument? Not? Can you find me an equation that has energy P and T in it and make sure the energy, the E, is by itself? I think you're right. I just can't hear. Energy equals? Yep. So the power, 60, time 18,000. On your calculators, folks, how many joules of energy will that be? I can do that in my head. It's going to be a 6 plus a 48. It's going to be 108. Is it a 108 with 4 zeros?
Yeah.
And energy is measured in joules. This energy is going to go over there. I'll show that by drawing an arrow, Marco, because that's the laziest but most organized way to do it. So David, my friend, we're nearly home. What energy am I going to put in here? Look up, kiddo. What energy am I going to put in right there? This number here, yes? 10840. Which time am I going to use? Now we're talking about the hair straightener, so we're going to use this time here. This question is probably more aimed at the females than the males, although males can use hair straighteners too. Hair straighteners, do they use a lot of heat or not? Are we expecting a high wattage or a low wattage? I'm willing to bet you're probably in the 500-600 range or higher. What do you get? Okay, yeah, that seems right to me. If you'd gotten 5 watts, you're moving a lot of heat around with those straighteners. They get hot enough to burn you pretty severely, right? What'd you get? Is it 900 even?
Yeah.
Okay. I usually put a box around my final answer. That's the equivalent of when a football player scores a touchdown and spikes the football. This is my little, I got the answer, touchdown. I think it's the last one. Yep. Good yawn? Last one. These are all what I mean multi-step. I'm not going to put 10 of these, Brooklyn, on your test, but I'll put 2 or 3. Okay? Halia, what's this one asking me to find? What is minutes a measure of? Oh, so I'm going to go T equals question mark. What's that 60?
Watts.
Which is a measure of? Good. What's that 564 200?
Joules.
A measure of? What letter? 564 200. Leah, I'm looking for an equation that has a T, a P, and an E in it, and has the T by itself, please. So it's going to be 564 200 all over 60. Go to your calculators. Practice typing these in. When you get an answer, Halia, let me know what you get. Get that? 9403 repeating. Units.
No.
Yeah. Time gives us seconds. Why are we wrong, though, for our answer? Can you read me the first 3 words of the question? How many what? How many what? What have we got? Seconds. So, okay, smarty humans. How do I change seconds to minutes? I know it has something to do with a 60. Is it times or is it divide? I don't know. I'm asking. Is it on your sheet? Or did I just say 1 hour equals 60 minutes equals 3,600? Okay. You want a dumb way that you can figure out whether it's times or divide without memorizing it, Leah? 60 minutes. Sorry, 60 seconds. How many minutes? How would you change a 60 into a 1 mathematically? Would you go 60 times 60? Or would you go 60 up? So if it works for 60 seconds, you divide by 60. It's going to work for 9,403.3 seconds. You divide by 60. So you can always reason your way there by picking a nice, easy number that you actually know the answer to. I know 60, 120 seconds is 2 minutes. The only way you can get that is to divide the 120 by 60. Old trick. So you thought I memorized all this stuff. I hate memorizing. I derive it. And I get 156.72. I'll call it 157 minutes. More than 2 hours, less than 3 hours. Am I wrong?
No.
Yeah, we're not done yet. And really, by the way, Jordana, what I should have done is I should have called this, and can you do this for me, everybody? Let's put a little part A right there and a part B right there. Let's put a part A right there, and then I'll change colors, and I'll call this part B. Hey, Jordana, so 157 minutes, how would I change that to hours? Ready? 60 minutes. How many hours is that? 60. 1 hour. How would you change a 60 into a 1? Times by 60 or divide by 60? 120 minutes. How many hours is that? 2. How would you change 100? But this is how I do a lot of my unit conversion. I've never memorized whether I divide or multiply. I always just make up a number that I know the answer to and ask, how would I change that into the answer? Would I times or would I divide? So you agree with me? Divide? Now, hey, don't use the 157. Use your answer button because the value on my screen is way more accurate. I wouldn't use a rounded off answer. Divide by 60. How many hours? 2.6? 2.61? If you weren't sure what we just did, you can make a little note. Divide minutes by 60. Or, Jordana, if you wrapped your brain around my stupid trick to figure it out by making up nice, easy numbers and you think you can rederive that, you don't have to write that down. No, I haven't told you the homework yet. Nice try. Question?
For hours, you have 2.61.
Yeah.
Minutes go to 60.
No. Okay? 2.5 hours. That's 2.5 hours. That's not 2 hours and 50 minutes. That's 2 hours and 30 minutes. 2.6 hours, that's going to be about 2 hours and 42-ish minutes, right? And this is part of our stupid time system. Our time system should not be out of 60s. It should be out of 10s. It should be 20 hours in a day, not 24. And our calendar system is stupid as well. It shouldn't be 30 days in a month. It should be 28 days in every month. And it should be 13 months. Get your calculators? Got your calculators? Everybody right now, get your calculator?
Yep.
Go 28 times 13. What do you get? 28 times 13. What do you get? So what you would do is you would have every month 28 days, exactly 4 weeks. So every Monday would be the same. Every Tuesday would be the same. And then that one extra day, because there's 365 days of the year, that's New Year's Day. You have a big party, and then you start the calendar over. Wouldn't that make way more sense? If I was the world dictator, that's one of the first things I would change.
So when your seasons change over
You just adjust it once and everybody would get used to it. It's actually, believe it or not, the fact that months aren't all the same length costs us billions of dollars because businesses can't compare last month to this month because last month always has a different number of business days than this month. And so it's very difficult to make accurate forecasts and accurate predictions. Stupid system. Homework. You're going to complete all of the following here on a separate piece of paper. I have put the answers in brackets. You don't do the one that's crossed out. You ready, folks? I took all of this from my Physics 12. See if you can handle it. 15 minutes, and you'll also get time on Monday. On Monday, we're going to be doing the circuitry sim, but I'm not going to be giving you new stuff. On a Wednesday, I think watch a Mythbusters video, and that way you can go into spring break without actually having to do homework over spring break.